So this is the second video about the paper that we have already started. We're already done with the first 10 questions. Now we're going to move to the next 10 questions from 11 to 20. So this 11 questions say that the diagram show 4 appliances and their power ratings. Which appliance transfers the most energy per second? Is it the iron or the TV or the toaster or the washing machine? So we have here power of each appliance. As we can see, if we compare between these 4, we have 1 kilowatt, 150 watts, 800 watts, and 3 kilowatts. The washing machines is consuming actually most of energy. Because of what? Because the power, as we already have seen, is the rate of energy divided by time. So if we fix the time, we see that the power is directly proportional to the energy. That means the answer for this question is the D here. So the appliance that transfers most energy per second is the washing machine. The next 12 here, an object is at rest. That means it's not moving on a horizontal surface. We have a horizontal surface. A certain object is at rest on it. Which equation is used to calculate the pressure that the object exerts? Is it A, B, C, or D? As we all know, the pressure as equation is the rate of force divided by area. Let's name it S. It's the force divided by area. That means we need to determine which area is containing the contact between the two objects, and what is the force applied on that area here. So for our case here, it's an object at rest. Because this object has a mass, that means it's applying a certain weight. The weight is mg, and this is the force for us. Divided by area of contact. This is the area of contact between the horizontal plane and the object. Which means, if we come back to the choices here, the question will have an answer as B. It's not the mass, because mass is not a force, but it's the weight. The weight is representing the force here. So weight of the object divided by area of contact is the pressure. Which device is shown? This is simply a manometer. It's a device used just to measure the pressure, or the pressure difference between two pressures for sure. The next is about which properties does a liquid have? We're talking about liquid here. So the definite shape and can be compressed easily. As we all know for sure, a certain liquid, it doesn't have a definite shape. That means it takes the shape of the container where it is. That means we're going to choose between C or D. So because of the liquid has not a definite shape, we're going to determine if either C or D by the second column here. Can be compressed easily. Liquids for sure cannot be easily compressed. We're talking about oil, water, any kind of liquid. It's not that easy to compress. It's not like the gases. So it's not that easy to compress the liquid, which means the answer for us here is D. It has no definite shape, and it cannot be just compressed easily. For 15 here, in the diagram, the black circle represents a smoke particle in air. Which diagram shows a likely path that the particle takes because of Brownian motion. When we say Brownian motion, that means a certain random motion. When we look at these four examples, the most equivalent for this situation is the C. This random motion is done by collapsions between the particle that we are talking about here and the air particles. If there is many of collisions between these two types of particles, that would lead to observe a Brownian motion or a random motion. So the C is the answer for our case here. For 16 here, which name is given to the change in volume of a gas? So we're talking volume of a gas when it's heated at a constant pressure. So the pressure here is a constant, and the gas has a change in volume at this condition, so the temperature for sure is increasing. When we increase the temperature, or when we heat in a certain gas, it's actually experiencing a certain expansion. Actually, it's an expansion. So is it a thermal capacity? It's not. Is it a thermal conduction? It's not. Is it a thermal energy? It's not. But it is a thermal expansion. Thermal because we are heating it, expansion because the volume would be increased as much as we heat in this gas. So the answer for us is D. For 17, we have this case. Some ice is slowly heated and its temperature is measured. A graph is plotted of temperature against time. This is temperature against time, and as we see, this graph is composed of three parts: this first part, and this X part, and this third part. The question here is which row describes what happens to the thermal energy and the temperature in section X here. So let's analyze this section X here. As we see, the value of temperature is the same, remains the same as long as we are inside this interval. That means the temperature is not changing. If we come to the temperature of ice, we can just choose between the B and the D. It's here where it states the temperature stays the same. So what's gonna make us to choose between these two is the first row here. So is the ice gaining a thermal energy, or it's not gaining this thermal energy? For sure, moving here from here to here, this is actually a period of time where the ice is being heated. So this energy, or this thermal energy, it's either increasing the temperature of a certain object, or it's changing its physical phase. That means for ice here, it's actually changing from ice to water. As soon as we reach the total conversion of the ice into the water, it will start again to increase its temperature in a liquid phase, which means the B is the answer for this one. So the thermal energy is gained by ice, and it stays at the same temperature here. For 18 here, the melting point of a substance is negative 78 degrees C, and its boiling point is 23 degrees C. So which row gives the correct states of matter of the substance at the given temperatures? We have here, it's like the same case. we have boiling point or melting point. Is at negative 78 degrees C. When we talk about melting point, that means it's where the solid turns to the liquid. And the boiling point actually is from liquid to gas. So this is at negative 78 degrees C, and this is at 23 degrees C. So let's talk about the choices here. State at temperature of 0 degrees C. Let's compare, or let's locate this temperature in this compared to these two values. We have here, this is temperature, and this is the melting point, negative 78 degrees C, and this is the 23 degree C. So here is solid, this is liquid interval, and this is the gas interval. Because we are at 0 degree, that means we are in this range here. This is the 0 degree, for instance. That means it's a liquid already. So for the second part here, states at temperature of 100 degrees C. 100 degrees C is greater than 23 for sure. It's already a gas. So 100 degrees C, it's a gas actually, which means that D is the correct answer for this question. The 19th question. A student set up an experiment to find out how will different metals conduct thermal energy. One in the overload of each metal is in hot water here, and the other end has a small nail attached to it by wax. This is wax, and those are the nails attached to these different types of rods. For sure, these rods will conduct heat, so this wax must be melting at a certain point to drop the nails. So comparing the timing of dropping of these nails will give us an idea about the conduct thermal energy of each metal. The rods have the same thickness, they have the same like dimensions. Which condition should be satisfied in order to make this a valid test? Same size nail, hot water kept at constant temperature, same length rod. So adding to this thickness that must be the same, we have actually make those rods made them with the same size also. That means we can choose between A, B, or C. The second thing is they have to be in the same length. That means it's either A or C. But when we come to the hot water kept at constant temperature, when we keep this water at the same temperature, means its energy or thermal energy is not changing. At this point, maybe this wax wouldn't be melt, so we wouldn't have any idea when this nail will drop. That means we actually need this water to be heated gradually or progressively. The Q or the thermal energy must be raised just like with the manner of a slow method. So what we need to say here is that the whole water mustn't keep at a constant temperature. Its temperature must be increased by time, which means the final decision must be the C here. So the rods have be in the same size. I mean the nails here, the same length of the rods, but the water must change its temperature with time. Finally, for this video, we're going to talk about the question number 20. So two similar metal containers P and Q each contains water at 90 degrees C. Both containers are the same size and both are sealed. The water in container P cools more quickly than the water in container Q. So this is the difference or the observation that we can see. Which statement is correct? Is it the P contains more water than Q, or P has a shinier surface than Q, P is painted a darker color than Q, or P is surrounded by a vacuum and Q is surrounded by air? So what determines this difference in evacuating energy is actually the color here. As we all know, dark objects can evacuate most energy or absorb the maximum of energy as they are dark. It's the opposite of the white objects. The white objects actually resisting the change of exchanging the thermal energy, but the dark objects, they are emitting everything or absorbing everything as a term of thermal energy. So because of this difference in color, that's what makes the P just like cools more quickly than the water in the container Q. It's not the A, it's not the B, it's not the D. So I hope this video helps you quick a little bit, and if you do have any question about what we have seen in this video, you can just drop them in the comments, and don't forget to like and subscribe in this channel so we can move forward. See you in the next video for the next 10 questions.